analytics, working primarily with public sector customers. I've been on this role for 4.5 years. And when I'm talking to public sector customers, I mean everything from central government, education, and healthcare, that type of thing. So today, I want to talk to you about the data and analytics on AWS, and the key drivers behind what's driving the industry today, and how AWS, how you can build a modern data architecture on AWS, right? We get to see some of the services. We'll dive a little bit deeper into some of the services that consist that you put together to build the modern data architecture, but also given that this conference is around climate. I want to present some of the kind of best practices around sustainability. And here I'm talking primarily about how to kind of, improve our carbon footprint for our data analytics solutions, because one of the things you could do with data analytics itself is, to analyze data to improve your carbon footprint. But that session is focusing primarily on, I want to build a platform on data and analytics, and I want this platform to be as efficient, and has the lowest impact for the environment as possible. So I'd start by recognizing, the few trends that are happening in the industry today. So customers, what we observe, talking to customers, is that their data is growing exponentially, right? And at the ever-increasing rate, customers tend to need to collect more and more data from their applications, their users, that sort of thing. But also, what is also clear is that the data is coming from different sources, right, from different systems. And this kind of variety also meaning that the data is increasingly diverse. That means, it's no longer anymore organizations that just have structured data. We tend to see a lot more semi-structured data or completely unstructured data. And all these is kind of a challenging data state for customers. And then what happens is, once you have that data, then there are all sorts of different questions that they need to be answered around the data. So customers also have a number of different tools and applications to analyze the data. So again, it's not anymore, one database with, some sort of SQL in front and that's it. Instead, customers now have more sophisticated tools. Of course, SQL plays a big role, but, we tend to see also, programming languages, Python, notebook environments, machine learning frameworks, data visualization applications, very different kind of usages. Of course, in the end, we've got different users, right? So different personas that perhaps have access to the data, from a data analyst to a data scientist that they might need to do machine learning on the data, all the way to a business and senior stakeholder who basically may want to see the state of the business using some sort of dashboarding solution. And really what customers are trying to do, they're really, it's kind of common pattern across all organizations. They're trying to put the data to work, right? Whether this is to drive better decisions, or what we call a data-driven organizations, to, take decisions about the future of the organization based on specific data. So collecting the data is one thing, but also making sure that you analyze the data and you understand the data is another thing. So improving their efficiency, faster response, faster decision-making, and opportunities. One of the opportunities, I have to say here, one of the opportunities that I might not focus too much on this presentation in terms of outcome of data analysis, of course, is sustainability, right? So organizations who collect data from their operations could actually use data analytics to improve their sustainability postures from data analysis. As I said, this presentation primarily will focus on the solution and the platform itself, rather than how to use the data, which obviously we're using the same set of tools. So let's see what how we can address that kind of challenging landscape and ecosystem, and how we could actually leverage AWS to put the data to work. And this is what we call a modern data strategy in action, right? So at the center, you have what we call a data lake. And I have to say here, this is not a service from AWS. This is a set of services that create some sort of paradigm and solution. You put together services to create what we call a data lake. So it's also a way of thinking about data, rather than just a solution. So at the center of it, we've got a data lake, which basically is storage for your data. A data lake will allow you to kind of store any amount of data, any format of data. And the idea there is really to, instead of having different storages that can perhaps make it difficult to do the analytics across all, to kind of centralize and create a repository for all the organization's data. Around the data lake, we have controls for governance and cataloging, just to make sure that we understand, what data we have available, given that we're going to collect a lot of data. Now, on the left-hand side, right, as well, you see the data sources. So the idea there is that different data sources could actually flow through to the data lake. And on the other end of this diagram, you see people, apps, and devices, which basically really is, empowering teams to kind of a self-service sort of culture around the data. Different applications, different devices, and different users can actually access the data and get insights from the data. But also you see around the data lake, or the central kind of catalog and governance, you get to see like purpose-built data stores, right? So while we do have the data centralized in one location, or or a data mesh, sometimes depends the organizations how they want to structure the data. We tend to have also the purpose-built data stores, so that you can get the most out of a particular data store to speed up a particular use case. So let's get to see actually in in a little bit more detail what that means, right? As I said, there are a few pillars, right? And we'll dive deep into each of those pillars. So a modern data architecture on AWS will start from a scalable data lake, right, at the center of it. And then around the data lake, a combination of purpose-built and cost-efficient data analytics engines that basically are ensuring that you're using the right tool for the right job, and at the lowest possible cost. We'll get to see some examples of what do we mean, and why do we need a purpose-built data store. But of course, very important is a unified data governance, right? A lot of the customers are actually requesting, how do we apply governance in a unified fashion when you have purpose-built data stores and also a centralized data lake. So I'll start my kind of, let's get one level kind of deeper into the the scalable data lakes and what it is. So at the center of it, our customers are using the service called Amazon S3 to store their data, and that's kind of the storage of the storage solution for data lakes. And Amazon S3 is actually an ideal service for using it, for the majority of your use cases for analytics and for being a persistent, data lake storage. Built on top of the AWS region, S3 actually is using, at least 3 availability zones within that region. It will never copy data outside of your region unless you request. There are some organizations who might want to copy data outside of the region for, compliance reasons, or for having the data closer to a particular application, what we call a cross-region replication. But by default, S3 will not copy data outside of your region. And S3, although within the region that you choose to create what we call a bucket, where you store your data, within that region, S3 actually will copy the data in multiple what we call availability zones. You can compare that to to a data centers type of thing, right? So that means you've got the data copied in multiple locations, and that's what allows S3 to have what we call an 11/9 of durability. So this is 99.999 11 times. So it's and also a lot of organizations can actually tick the disaster recovery box as well, because a lot of the times you need to have the data in multiple locations just in case one location actually is unavailable or fails. So all that you get by default in S3. But also what is important is S3 is actually a very it's a very established and solution. It's the one of the oldest AWS services, and the entire kind of Hadoop open source community is integrating very well with S3, let alone AWS partner or ISV. So there are lots of solutions actually are working natively with S3. Now, how do you use S3 when it comes to data lakes, right? So customers actually store primarily using open formats. They're storing the data using open formats. What do I mean by that, right? So for example, CSV files or JSON files, or more analytics kind of focused files, such as columnar files, like Parquet. S3 allows you to store any amount of data and any file size, right? So from that point of view, it won't give you any limitations. Therefore, by choosing now open formats, storing whatever amounts of data do you need, that allows you to decouple and really use the analytic process that makes sense for your data and the analytical tool. A lot of those tools actually query the data in place as they are in S3, eliminating the need to bring the data into that analytical tool. And that brings me into the kind of a second pillar I wanted to kind of highlight. What are those purpose-built analytical tools? So we've mentioned that from one side we've got our data in an Amazon S3 data lake, and then purpose-built services around the data lake. And the idea of using purpose-built analytical services is really to optimize perhaps a particular use case. I'll give you an example. Let's start actually from Amazon Redshift as one of the key analytical services that customers are using today. Amazon Redshift is our cloud native data warehouse, which is built for the cloud. And Redshift is integrating very, very well with Amazon S3 data lake, right? The fastest way and the most efficient way to load data into Redshift is to copy from S3, right? And what the Redshift will do is a parallel system. So, you can have, the data loading in parallel from, different nodes of Redshift fetching from S3. And of course, the more nodes you have, the more parallel and the more parallel the loading of it is going to be. Also, the Redshift has the ability to export data out to the data lake. So for example, let's say you load some data into the data warehouse, you do some analysis by your data analyst team, and then you want to export that output of the analysis back to your data lake so that is available for other analytics or other use cases. Perhaps the data science teams wants to get access to that particular report. So again, the unload command, native command, sends data back to S3, and you can actually do some conversions on the fly as well, such as convert to a file format that is very good for analytics, as mentioned, Parquet. But last but not least as well, Redshift actually is able to query, apart from the data that you load into Redshift, and is to get the most out of it in terms of performance. Redshift can actually query the data into the Amazon S3 data lake. So that means I can combine the data that I have in my data warehouse with the data I have in my data lake. Then, you would ask, why would I want to do that? Well, a lot of the times, data that is in the data warehouse are those kind of high quality prepared data for reporting, while data in the data lake could be, logs, could be, events, could be older data, could be more historic data as well. So giving that ability to be able to compare, trends or data quality, or just to do some sort of infrequent querying back to your data lake, just to, to extend the view of what your data wants to tell you, basically. So these are quite powerful. We call that Redshift Spectrum. This is kind of the feature that allows Redshift to query data directly into the data lake. Another service I'd like to highlight is Amazon Athena. So Amazon Athena is an interactive query SQL engine. It's completely serverless. What that means is that AWS, will scale the service for you, and you just submit your queries, and you pay per query, and that means how much data you scan. That will affect the price of the service. So you don't need to provision any servers. You don't need to do any kind of estimation on how many servers you need to, how much memory. AWS will do that for you. All you need to do is to write your queries. Athena is great. It works with Amazon S3, but also now we've got a external connector marketplace for Athena, and basically customers can connect to external data stores. Behind the hood, Athena is using Presto, and we're really leveraging those capabilities of those data virtualization capabilities that Presto has to reach out to the kind of those external data stores. There is an ever expanding actually list of connectors, but customers can actually create their own connectors. So if you have a proprietary data store that you want to connect Athena to, you can actually build your own connector as well. For big data workloads, we've got Amazon EMR. And when I say big data workloads, because big data is also Redshift and Athena, I'm really meaning primarily those open source solutions that are coming from the from the kind of Hadoop ecosystem. I'm talking here about Apache Spark, Hive, HBase, Presto, and Trino. These are among the services that exist on EMR. EMR is a service of services, really. Like it's a toolbox that contains a lot of open source solutions, and customers leverage it in very different ways. It works directly with S3 as well. We have built a set of libraries that allow EMR to talk to S3 in a very cost-effective and secure way. And we also have built a runtime for Spark, which is actually quite significant development, and it improves Spark performance by a large margin when it compares to, for instance, open source Spark. Of course, the compatibility with open source remains. So that means if you do have Spark workloads and you want to use EMR with data on S3, we can actually bring your scripts and just point to the day where the data is. Most likely those will run on EMR, because one of the things actually we do on EMR, you can actually choose the version of the application that you want. Again, this is one of the, perhaps I don't know other managed services that you can do that. Most of the times, you get the latest version, or something. But here, you can really go back in time, many versions. And the reason is that, because it's open source solutions, not always those frameworks are backwards compatible. And sometimes customers want not to get the latest, sometimes they want to get the specific versions that work with their code and their application. So they have those choices to do it with EMR. And before we move on, just to mention, for log analytics, customers are leveraging Amazon OpenSearch service. And for streaming data, we also have solutions and services. Amazon Kinesis is a family of services that allow customers to store or deliver or analyze their data real time. Specifically, Kinesis data streams is where you got to put your data to be then analyzed by other applications. Firehose, Kinesis Data Firehose, is one of the data streams that reads from, you either put the data direct to the Firehose or can read from Kinesis data streams and then deliver to a target for, later for other analytics later on. It's very common actually for streaming data that all you need to do is to deliver to to a target, and you might not want to do the analysis on the fly. You might want to just deliver and then do analysis later. So 2 common targets among others, or 3 common targets, let's say, among others is S3, which I would say is the most common. Then Redshift and OpenSearch are also among the supported targets. We also have partner products such as Splunk to deliver from Amazon Kinesis data firehose, and of course Kinesis data analytics there. So customers are leveraging Flink to really analyze the data on the fly, basically. For example, when you have use cases such as I want to calculate a moving average on my streaming data, and you want to fetch some data, do your calculations, and then perhaps store the calculations back to your another stream or to the S3 data lake. This is where you would use Kinesis data streams, Kinesis data analytics, sorry. And Manos service for Kafka is let's say, from a use case point of view, equivalent to Kinesis data streams is obviously for a Manos service for Apache Kafka. And then customers can also leverage, the Kafka ecosystem around it, right? So there are a lot of kind of different solutions and services around Kafka. Right. Moving on, another important component is data governance. And it's actually impossible to talk about data governance without mentioning AWS Lake Formation. So Lake Formation has as a service, right? So it's something that helps customers manage their data lake and build their data lake. So there are various steps where Lake Formation actually helps you with to create that data lake. Starting with when you build a data lake, right? So you register your location within Lake Formation. Second, I have a little audio-visual issue. So you register your Lake Formation so you register your data location with Lake Formation, and then Lake Formation then gives you what it's called a blueprint. So basically you can define a kind of a predefined way to load data. So we've built some common ways to load data from those relational stores, for instance, into a data lake. That's an example, or an incremental load into an S3. So Lake Formation allows you to really simply, use those pre-built blueprints and, hydrate your data lake. Some of the common transformations, like converting to Parquet. These are all built in within our service as well. So it's kind of makes it as well easy. It's leveraging what we call AWS Glue behind the scenes. There is another service that allows you to do that. But where it really Lake Formation simplifies things is when it comes to security management. And we have to think a little bit, what was the case before Lake Formation, right? So when you use IAM to control access to objects and data and users, and that applies the same to metadata. And then Lake Formation kind of sits on top of IAM for the datasets where it is enabled, and allows you to give access to users and groups with a familiar, I'd say, grant sort of statement, like as you would do in a database. But it goes also further. Lake Formation allows you to have richer controls over your data, such as, column level security, when you want to hide, for instance, a particular column to a particular user, or to have row-based filterings, right? So again, for those use cases where particular users need to see only a subset of your table, and then you apply a filter on the fly as you query the data. And last but not least, Lake Formation introduced a tag-based policies, right? So that means you can actually tag your tables and then give permissions to particular users or group based on specific tags. So think here, like you can actually create a data classification tagging strategy, tag your data from being, less sensitive or very sensitive. And then based on those tags, you can actually define which group can see the sensitive tags and which group can see only the non-sensitive tags. Also, those sophisticated access controls I've mentioned earlier, the filtering and the column access also can be used in conjunction with the tags, right? So it's a quite powerful way to to control your your access to the data. And finally, also lake formation allows organizations to capture additional metadata around the data, right? So here I'm talking such as, we've mentioned the tags, but there are also things like, just describing a particular data set, what it is about, right? So this kind of information can help your analysts around the organizations to be able to understand the data, explore the data, and then get to see what data set they want to use or access for their particular use cases. That kind of drives customers towards, help customers go towards kind of what we call a self-service access to the data. And in order to achieve that, you need to have good descriptions around what your data is about. Otherwise, customers and and users will get lost if they don't know where to look with the data. And that kind of at the high level gives you a a blueprint of what are the main data analytic services on AWS, and how would you put them to create a modern data strategy. But at that stage, I wanted to also talk about some of the sustainability element of this, right? And I want to mention, perhaps you might have seen that from other AWS presentations today, but I want to mention the AWS well-architected framework, right? So when we created the well-architected, we really targeted the cloud architects to help them build secure, high-performing, resilient, and efficient infrastructure for a variety of workloads and applications. And traditionally, we started with 5 pillars that you see listed there, like the operational excellence, security, reliability, performance, efficiency, and cost optimization. And as of in this reInvent, last year's reInvent, we now added a sustainability pillar, and that actually allows you. What we are aiming to do there is to provide you a consistent kind of advice on how to build sustainable best practices and identify areas of improvements when you build your architecture on AWS. And it really has questions around how would you manage this, how would you manage for instance your how much data movement is there, or how do you select the region, that sort of thing, where you can actually start thinking about if you have the right policies in place to build sustainable solutions. And now you'll see, a white paper. Well-architected is a white paper that you can actually go and download and get to see, specific answers to sustainability questions and best practices. But what I wanted to present on this session is actually, how do we apply these best practices when we build data and analytic solutions? So here are some of the kind of tips and best practices that I could actually gather, and certainly would help you build sustainable data analytics solutions on AWS. So I'll start by, let's move on. So best practice, I'll start by, the simple and easy, use serverless where possible. And the reason behind serverless is obviously, a lot of the things, when it comes to sustainability, right, a lot of the focus is that you provision as much as you need, right? That obviously is something that will decrease, your carbon footprint. Obviously, over provisioning is, taking towards the other direction. So really avoiding over provision is the key goal here. Now, how serverless avoids over provision? Well, the actual answer is simple. So a lot of the times, in these serverless solutions, what AWS do, it's handling the management of the servers for you, while you only have to focus, perhaps for the code that you run on those services. And in reInvent, we announced a number of serverless services when it comes to data and analytics. Just to mention a few, right? For data warehousing, we now have Redshift serverless. Customers define Redshift units, and then the service itself will scale for the number of queries and the amount of queries and the amount of processing a query needs. So this is, again, a way for customers that not to have to provision capacity when it comes to Redshift. Instead, they can actually use serverless. For big data core processing, we've built EMR serverless. For real-time analytics, we have the MSK serverless, the Kafka service we've mentioned earlier, but also Kinesis data streams on demand, where you pay only for the amount of data that you stream through to Kinesis, rather than having to provision shards, where sometimes you might over provision just to catch a particular edge case or a spike in your data. Since 2017, we have AWS Glue that is running serverless Spark. Now I need to also mention that Glue comes with auto scaling as well, so that allows you actually to create to start from a starting capacity and then let Glue auto scale as your job requires more and more workers. And Lake Formation, of course, is serverless. You kind of use it and you apply the permissions. And QuickSight for data visualizations is also serverless. And Athena as well is serverless. We've mentioned that, where the SQL querying engine, where you just submit your queries, and AWS scale this system for you. So this number of serverless options for you to use, depending on the use case, and by adopting these managed services, actually, you get to leverage the best practices that AWS applies when it comes to managing those services, and sustainability is at the forefront of how we manage those services. So that's the first kind of aspect. Another aspect is the data movement. Right. When we look at sustainability of the workloads, one of the drivers could also be summarized into how do I avoid data movement, and why data movement is bad, right? So unnecessary data movement might be bad, because sending data or large amount of data over the network is energy consuming and costly exercise. So for a good sustainable architecture, avoiding unnecessary data movement is actually a very good practice when it comes to sustainability, let alone the cost as well. And there are a few features that I want to highlight that help customers avoid that unnecessary data movement. And here I'm talking about federation and federated queries. And services such as Redshift and Athena have those kind of abilities. Now, let me specifically give you some examples. So Redshift, we mentioned about Redshift that there is the Redshift Spectrum, right? So it gives you the ability to query into Amazon S3 data lake. Likewise, Athena gives you that ability to query AWS to query Amazon S3 data lakes. That means that you don't need to move data, into an analytical store. Data stays as is, and then you can query the data from your analytical engines into S3. But also, sometimes you might have other data stores outside of S3, right? And Athena, we've mentioned about the connectors that you could have and query the data in place with that federation. That then means that you don't have to load the data from that database into Amazon S3, let's say, but you could actually have that connection and leverage that connection whenever is needed. The other thing is Redshift also has a federated query capability with Amazon RDS and Aurora PostgreSQL, right? And that allows you again to query those relational databases from your data warehouse. Now, some of the use cases around these features really comes to kind of extending what your data lake queries can do, and perhaps extending and joining with information that you find in those relational data stores. But at the same time, if we do have a lot of frequent queries, for instance, on those external data stores, we might consider actually bringing the data in. So, and this is a key thing I want to highlight here when I say unnecessary data movement, right? It's not just, don't move the data at all. There might be times where your data needs to be moved into that data lake, and that is the best thing to do. But when you have data that are infrequently accessed perhaps, and you don't need to move them, then don't move them, right? Leverage the federated querying capabilities for those use cases and avoid creating any, complex ETL pipelines. And that kind of brings me to the second example where, okay, what if I have a frequently accessed data? How does that unnecessary data movement policy and principle applies? And here an example is Amazon QuickSight, which is our visualization platform service. And QuickSight, obviously, you're familiar with data visualization tools. A lot of the times they query a lot of the data, and they might need to submit a lot of queries, and they need to bring the data back to visualize. And you might have multiple dashboards, each of which might send a query back to your store, to data store, to get the data to visualize. Or you might have a lot of users. You might have tens, hundreds, or even thousands of users connecting to your BI tool. So those, there are a lot of queries there. So in that particular case, for instance, an example where that virtualizations, wouldn't be a good idea to go for every query to reach out to these kind of data stores. So instead, there are other features where you actually bring the data very close to your visualization platform. That would be a way to minimize data movement, right? Instead of going and reaching out directly to where the data is, for this particular case, I should consider bringing the data close to my visualization platform for faster performance and for less data movement, because this data is so frequently accessed. QuickSight has an engine called SPICE, stands for super fast processing calculation, in-memory calculation engine. And what it allows you to do is to really load the data from your data stores into SPICE. And that then allows you to kind of think of it as a caching layer to a degree for your visualizations. You can auto refresh so that your data stays fresh as within that kind of hour of the auto refresh schedule that QuickSight supports. And this is again another good way to avoid unnecessary data movement. Moving on, it's worth here mentioning some of the best practices around optimizing for data lakes, right? And of course, storing again as much as you need is very important, and minimizing the data yet you need is also important. This is where compression comes in, right? Compression might not give you performance benefits, but it will come with cost benefits. And of course, the least amount of data you store, the less your carbon footprint as well. So compression is a really good practice to apply for data in the data lake. Partitioning, though, is even more important, I'd say. So partitioning really is when you use the partitioning strategies in combination with your, querying, with how you query your data, you can actually, you use a lot less processing, right? That's where the optimization is. And therefore, the less you need, the lower your carbon footprint is going to be, because, the more processing the other way around as well. So the less processing you have, the less your carbon footprint. And the idea around partitioning is really simple. Don't scan more data that you need to scan. An example here, a lot of the times partitioning, as seen in the slides, is temporal data, right? Temporal columns where you might have a date, a year, a month. Think of a query that runs for a monthly report. And you don't really need to scan anything else apart from that particular month that holds that data for your report. So let's say now is September. Let's say I want to run today a report for August. I only need to scan the data for August to get my report. I don't really need to scan the data for July. So in order to achieve that sort of simple task for data lakes, we use partitioning, right? So the partition column, for instance, in that example could be your, the month, the calendar month. And in your query, you define your, as a where clause that the month is, let's say, August. Because of the partition and the way you store the data, all the data that of August, for instance, will be under the same kind of folder into the S3 data lake. That's kind of how partitioning really works. scanning less data is significant, right? If you think about that particular example with the month, every year has 12 months. Let's say we store 5 years worth of data, that's 60 months. If I scan only one, it could be 1/60th of the amount of data that I need to scan. So it can be really significant, right? Depending on how our queries are. So bear that in mind when it comes to building data lakes. A few more tips for fine-tuning. Again, that choosing the data type is important when it comes to optimization. Again, the same principle here. When you're optimizing your data analytics, actually it results to less amount of time for processing. That then needs less amount of compute. Therefore, that can actually correlate to a improved carbon footprint for your organization. Redshift, we have, some best practices, for instance, in our data warehousing, documentation and Redshift documentation. A few examples, for instance, avoid having very large columns that they might take more memory than needed. Use appropriate timestamps, for instance, when you have a timestamp, that's important as well when it comes to storing that data. Avoid oversizing bar charts, for instance, right? So make sure you understand, and apply some perhaps data quality metrics when your data arrives. See, how is the maximum length of that column, and then perhaps fit that into your data, data definition language when you create your columns. Another tip and tool for improving is materialized views, right? And the reason I call them here materialized views is because a lot of the times, when it comes to, again, for data analytics, right, you might have complex and heavy data querying, right? Queries that might be heavy, result in heavy processing, and those queries can actually repeat, right? So there might be multiple users who are querying that sort of similar kind of heavy processing. And it's very important to sometimes, to kind of pre-calculate those queries, right? In some sort of materialized view. That's what we mean here. Business intelligence use cases are perhaps ideal for those materialized views. Redshift now supports materialized views. Materialized views can refresh automatically, right? As the data change, the underlying data change, materialized views can automatically refresh. And also a new feature of Redshift is the automatic query rewrite. What that means is even if your query does not reference a materialized view that you've created, Redshift actually evaluates whether there is a materialized view that actually will benefit your query, and then rewrites that query to use that materialized view. So it's really important actually to leverage the materialized views of, for instance, when we have data warehousing with Redshift, so that we get the performance benefits for our use cases. And as I said, performance benefits means less need for compute. Less need for compute, then it brings us to a better carbon footprint for our organization. Moving on, I just want to bring everything together and just highlight what we discussed today, right? So from the left-hand side, you see the data sources. This can be various data stores, data lakes, but also on-premises data systems, or even other clouds, then that you bring the data into AWS. Then with lake formation, you manage the access around the data. And then with the ETL services and the data preparation services, you can prepare the data around what you have in your data lake. Here examples, the Glue Data Brew or SageMaker. We didn't dive deep into those two services, but this is for the kind of data preparation phase. SageMaker is a full AI ML platform. And then a kind of the end right-hand side corner, and Amazon QuickSight, our visualization service that allows you to actually connect to those prepared data sets and visualize them so that you can actually find insights. And just to recap, today we saw the modern data architecture on AWS. I hope that's now clear. But also we discussed some of the best practices around sustainability when we build data platforms, how we avoid data movement, how do we optimize for our data lake, and how to and when to move the data or when not to move the data when it comes to various analytical use cases. Also, we've highlighted some features that help customers improve their sustainability postures when it comes to analytics. And I want to also mention that we have we're working on a we've mentioned the well-architected framework. There is also what we call the analytics lens on the well-architected. So what that means is that you've got the pillars as described in the framework, but from a data analytics point of view. So there are a different set of questions with the same mindset. So we are working on a sustainability pillar for the analytic lens. So it's something that will be published over the next few months as a white paper. So keep an eye on the new revisions of the well-architected framework analytic lens. This concludes my presentation. I want to thank you for your time, for your participation. I hope you find it interesting. Looking forward for your feedback. And back to the host on the potential Q&A session or break. It's up to you.
Thank you, Manos, for this very informative session. For attendees, you can just write your questions in the chat, and Mr. Manos will be more than happy to answer them. We have 5 minutes for that.
I don't see any questions. Feel free to share thoughts, any feedback.